Our final section in our topic of proportions is scale drawings. So scale drawings are super easy, and they're just another extension of proportions. They are proportions, really. And you see these quite often in your standardized test questions because they can use that in so many different applications. We're going to follow our same steps. We're still going to write line equals line. We're still going to complete the first full ratio, transfer our labels over, fill in the third number, draw an arrow and circle. So we're following the same method. We're just doing it, we just have a different type of problem. So looking at this picture, now this is the kind of stuff that like people in construction and architects and things like that would use, because they would draw the building that in a smaller version and give you a scale. And then you need to know, like if you're building this, you want to know if the window on your picture is 3/4 of an inch, you got to know how big to actually draw it. So what happens for your proportion problems with scale drawings is, let's turn this light off while we talk here, is if your scale is 1/2 inch equals 3 feet, anytime you have the scale given to you, that's the dead giveaway that that's your ratio. So your scale becomes your ratio. That first ratio that we said, the complete ratio that we used to fill in that first fraction line. So when you look at your problem and you put your line equals line, just like we've done before, and my scale is 1/2 inch equals 3 feet, don't worry about the fraction, okay? 1/2 inch equals 3 feet. Transfer inches to feet across. And let's just say I'm looking at the bay window and I need to know how big to build it in real life. It's 3/4 inch on the paper. So where am I going to put 3/4? On the top, because that's where I have inches. Then you just draw your arrow and circle. And so how big does your bay window need to be? Just get your calculator out. Don't forget that you can just work your calculator with your fractions. It's so easy. So you got 3/4 times 3 divided by 1/2. Don't worry about the fraction, just put it in there. And so, oh, that's a good one. It's improper. So if it's improper, we say second times 10 to the n. Remember that? So 4.5 feet. So that's how big that would be, 4.5 feet. All right, so let's just do a couple and show you how these work. So I'm going to be working on these problems. If you're one of my students, you can just follow along with me on your material. But I want to show you a couple that they're not harder, but they just kind of are arranged differently, so you might not catch it. Okay, let's look at number 2. On a map, Ludwig is 2.8 centimeters away from whatever. Whoever knows how to say it, doesn't matter. If the map scale reads this, okay, so this is your scale, just like your scale was given to you over here in this picture. So this is my scale. I know that's going to make my first ratio. How many miles apart are Ludwig and Quintana or whatever? Okay, so they gave me a scale. I know that's dead giveaway for proportion. So I'm going to write line equals line. I'm going to take the scale and fill in my first complete ratio, but I want you to notice they gave you this 2.8 centimeters first. And if you're one of my most regular people that I get, they get this problem, they read it, they know they're doing proportion because they've been doing proportion for 5 pages now. So they just go 2.8 over 1 centimeter equal. And you see what they did there? They just took the first number they saw and put it down. Second number they saw and put it down. And this is what I call being a number lifter, and that's not a good thing. You don't want to be a number lifter. That's why I put number 1 is to read the problem. So when we see its scale, I go in here and find what I need very specifically and put it down. So I have 1 centimeter and 300 miles. Got that right off the paper. And it's not hard, it just wasn't in the right order. Boy, don't you hate it when they change the order? Then we take centimeters and miles and put it across. Now I can take my 2.8 centimeters, put it up here, put your X, draw your arrow, circle, got your answer. Okay? Multiply and divide. All right, now let's look at another one. So, let's see which one we're doing. Okay, let's do this number 6. I'm trying to look for some that are a little different, so you won't have them all the same kind. A map maker uses the scale. Oh, when they give you scale, that's dead giveaway, that's proportion. We can just almost automatically write line equals line. Gives us a scale of this. How many centimeters apart should Arlington and Corpus Christi be? So I'm going to go ahead and fill in my scale. We've got 1 centimeter and 20 kilometers. See how I got it out of there? So I've got centimeter, kilometers. Now I've got to go to my chart. They incorporated a chart on this one. And we're looking at Arlington to Corpus Christi, and there it is there. That's their approximate distance in real life, so 550 kilometers. So notice I've got it labeled here. So I want to put 550 there, and then multiply and divide. Okay? All right, so let's look at one that's a little different. All right, let's look at number 8. It's a little bit different. On a map, Grand Prairie and Mesquite are 18.5 centimeters apart. So now we're talking about on the map, they're that far apart. How many centimeters represent 1 kilometer on the map? This is backwards. They didn't give you the scale like they did up here. They're giving you how far they are on the map, how far they are in real life, but you don't have the scale. So that's where that one is tricky. Whereas before we just wrote the scale down, always started with a scale, that's easy schmeezy. This one's not so much, okay? So we know that Grand Prairie and Mesquite are this far apart on the map. So we know they're centimeters apart, but in real life, they're 37 kilometers. So we have centimeters to kilometers. And then we transfer that centimeters to kilometers. Then we look again at our problem. How many centimeters don't have centimeters? Represent 1 kilometer. 1 is a number and you can use it. A lot of students don't like to use the number 1, okay? So now we see our numbers are diagonal this way. It's a little bit different position. And we circle, multiply and divide, and that should give you the number of centimeters they should be on the map. Okay, one more. Look at this picture down here. This is what they give you. What is the length of the rod in feet? Okay, that's proportion. So, because it's scale, it makes it proportion almost identical. I mean, almost immediately, you know that. And they gave you the scale right there. No thinking even involved there. Transfer your labels over. Don't skip your steps. Now the question is, what are they talking about length and height on here? Well, L, length, is usually for the long L side. Okay, so that is my length. This is my height. But sometimes we hear length and width. So that kind of throws some of my students off. So we're using 1 7/8 of an inch right here. That's a mixed number. It's okay. And then we're going to come and multiply and divide, look for the number feet. Okay?